This is space, vast, extreme, and full of mysteries. Beyond the stars lie worlds more terrifying than we ever imagined. We will travel into space to explore them, leaving Earth behind to reach the most horrifying planets discovered so far. We have to leave now. We board our primary spacecraft, prepared to depart from Earth. The takeoff sequence begins.
SRO is go. CDI is go. Launch director, NTD, our launch team is ready to proceed at this time.
The engines roar beneath us, powerful and relentless, breaking free from gravity's hold. The craft trembles as it ascends. Soon the roar of the engines fades and gives way to silence. We breach the atmosphere and enter orbit around Earth. Yet this quiet moment will be brief. The timing is critical as we execute a Hohmann transfer orbit perfectly aligned with Venus's path. At the perfect moment, our engines ignite, sending us beyond Earth's orbit on an elliptical course, reaching out to meet Venus as it journeys around the Sun. Earth becomes a shrinking blue dot, our small home in an endless void. Weeks pass as we coast along the curve, slowly drifting away from Earth's pull. The Sun's gravity draws us closer, guiding our path inward toward Venus. The timing is just right, and soon our spacecraft lines up with Venus's orbit. Venus comes into view, a swirling sphere of thick clouds and golden light. As we approach, the engines fire again in a precise orbit injection, a critical burn to slow our speed and adjust our path, allowing Venus's gravity to pull us in. We slip into a stable orbit, our spacecraft hovering above the dense clouds of this fiery world. But beneath its beauty is a harsh and unforgiving place. The surface burns at 470 degrees Celsius, 880 degrees Fahrenheit, and the atmosphere is packed with carbon dioxide so dense that it exerts 90 times the pressure of Earth's air. The clouds are full of sulfuric acid, forming a corrosive mist that dissolves anything it touches. The day on Venus is longer than its year. A single day lasts 243 Earth days, and the planet spins slowly in the opposite direction to most planets in our solar system. As a result, sunlight heats the surface for months, creating temperatures that never cool down. The winds in the upper atmosphere reach speeds of 360 kilometers per hour, or 224 miles per hour, whipping around the planet and making the sulfuric acid clouds swirl at a speed far beyond the surface's slow rotation. Venus is a world of extremes: intense heat, crushing pressure, toxic air, and relentless winds. A planet where life as we know it could never survive. And here, in this dangerous orbit, we hover, just out of reach of its burning grip. In the shadow of Venus, a massive vessel awaits, our warp ship. It's unlike any craft humans have ever built, capable of traveling distances that would take thousands of years at conventional speeds using orbit transfer and slingshot maneuvers. This spacecraft can warp space itself, a concept rooted in theoretical science and based on the ideas of general relativity proposed by Albert Einstein. Instead of simply accelerating, the ship bends the fabric of space-time around it, enabling interstellar travel. We transfer into this larger vessel and secure everything for the journey ahead. The hum of the engines grows, and the ship's core begins to glow. Then, in an instant, space-time stretches and distorts around us. The stars stretch into long, bright lines, and we leap forward. This is warp travel, beyond the speed of light, beyond the edge of our understanding. Within seconds, we're no longer orbiting Venus. We're speeding through the depths of space, ready to visit worlds more extreme than anything we've ever imagined. The warp field collapses, and suddenly, we're somewhere entirely new. Gliese 436b, about 30 light-years away from Earth, in the constellation Leo. At first glance, it seems like an ordinary ice giant orbiting a cool, red dwarf star. But this world defies expectations. The temperatures here soar to over 400 degrees Celsius, 752 degrees Fahrenheit, hot enough to melt any ice we know. Yet somehow, this ice remains solid. How? Gravity. Gliese 436b's intense gravitational forces squeeze water into an exotic form called hot ice, where the molecules are locked in place despite the heat. Imagine ice that doesn't melt, but instead burns. A dense, compact surface where water defies the natural rules we're used to. The planet orbits its star closely, completing an orbit in just a few Earth days. As we pass over it, Gliese 436b gleams with a haunting bluish glow, a world that shouldn't exist, yet does. We adjust our course, preparing for the next leap across space. The warp field shifts, and we emerge near our next destination, 55 Cancri E, about 40 light-years from Earth, in the constellation Cancer. It's orbiting 55 Cancri A, a bright star visible to the naked eye from Earth. But while the star may look peaceful from afar, its companion planet is anything but. As we approach, 55 Cancri E reveals its blazing secrets. The planet orbits its star so closely that a year here is just 18 Earth hours. One side of the planet is always facing the star, locked in permanent, scorching daylight, with temperatures climbing up to 2,400 degrees Celsius, 4,350 degrees Fahrenheit. Rivers of molten rock flow across the surface, creating a fiery ocean of lava. Meanwhile, the night side, shrouded in eternal darkness, remains just as extreme, with temperatures still around 1,300 degrees Celsius, 2,370 degrees Fahrenheit. But the planet holds an even more fascinating secret below its surface. 55 Cancri E is packed with carbon, which, under immense pressure, forms layers of diamond. Imagine a world where diamonds are as common as rocks, hidden beneath a crust of lava and superheated gases. The entire planet sparkles like a jewel, a diamond burning in the depths of space. The ship adjusts its position, taking in the view of this fiery gem before we jump to our next destination. The warp field envelops us again, bending space-time and delivering us to Dimidium, orbiting the star 51 Pegasi, about 50 light-years from Earth in the constellation Pegasus. This was the first exoplanet ever discovered orbiting a sun-like star, a massive gas giant that appears almost serene from afar. But beneath its golden clouds lies an atmosphere that defies our expectations. Winds howl at over 1,000 kilometers per hour or 620 miles per hour, carrying vaporized metals like iron through the dense clouds. As these iron particles cool, they condense and fall as molten metal rain, a storm unlike anything we could ever imagine on Earth. This hot, roiling world orbits its star so closely that its surface temperature climbs to around 1,000 degrees Celsius, 1,832 degrees Fahrenheit. The effect is mesmerizing, a planet wrapped in storms of liquid metal. Warping through the void, we drop out of the field near HD 189733b, a planet orbiting the orange dwarf HD 189733, around 64 light-years from Earth, in the constellation Vulpecula. From a distance, this planet glows a stunning blue, much like Earth. But that's where the similarities end. Its winds scream across the surface at 8,700 kilometers per hour, or 5,400 miles per hour, almost 7 times the speed of sound. But it's not just the wind. The atmosphere is laced with silicate particles, forming sharp shards of glass. When it rains, these glass shards fall sideways at terrifying speeds, ripping across the surface in relentless horizontal storms. To touch down here would be to encounter a world of relentless cutting winds, an environment where survival is impossible. Space bends once more, and we find ourselves at TOI 1452b, orbiting a cool red dwarf star around 100 light-years from Earth in the constellation Draco. At first glance, this super-Earth appears covered entirely in water, an endless ocean stretching over the entire planet. But this is no familiar sea. It could be thousands of kilometers deep, and the pressures in its depths are like nothing on Earth. These immense pressures likely transform water into exotic forms, supercritical fluids that blur the line between liquid and gas. What mysteries lie beneath this alien ocean? It's a question we may not be able to answer, as the waves and pressure of TOI 1452b hide its secrets well. We warp again, and Kepler 70b emerges before us, about 400 light-years away in the constellation Cygnus. It circles a subdwarf star, Kepler 70, so closely that its orbit takes just 5.6 hours. Once part of this star, the planet is now a rocky core, stripped of its gaseous layers by the star's intense heat. Kepler 70b's surface temperature soars above 7,000 degrees Celsius, 12,600 degrees Fahrenheit, even hotter than the surface of our Sun. The planet is a scorched remnant of what was once a gas giant, now reduced to glowing rock. And if that weren't extreme enough, it often passes another planet in its system, Kepler 70c, at a distance of just 240,000 kilometers, 150,000 miles. The closest two planets have ever been seen passing each other. With one more warp jump, we reach Corrot 7b, a super-Earth orbiting Corrot 7, about 489 light-years away in the constellation Monoceros. The proximity to its star means that the surface temperature soars to 2,600 degrees Celsius, 4,712 degrees Fahrenheit. Here, rock vaporizes into the atmosphere, creating thick rock clouds. When the vapor cools, it condenses into tiny stone particles, raining down like pebbles onto the surface. Beneath these rock clouds lie vast oceans of molten lava, constantly churning and shifting as the planet orbits its star in just 20 hours. Corrot 7b is a planet of liquid rock and falling stones, an unimaginable world of constant geological upheaval. Each of these 10 planets reveals a new layer of the universe's extremes. These are worlds that stretch our understanding of what planets can be, challenging the limits of survival and defying every expectation. As we prepare to dive deeper into the vast unknown, one thing is clear: this is just the beginning. The universe holds countless more secrets waiting to be discovered, worlds more alien and fascinating than we dare to dream. If you'd like to be part of the next journey, don't forget to like and subscribe so you don't miss out on our upcoming space explorations.